Thank you about that. So again, good morning, everyone. Thank you for giving us an opportunity to share our solution for this e-learning for electronics. So actually, an online education nowadays is very popular because of the pandemic. And because of that, so most of the universities and colleges are now looking for a solution to have their own online e-learning system. Okay, and then there are some university already have their own educational online education system, but some of the schools right now are in the process of making their own e-learning content. So e-learning nowadays is very important because even CHED, TESDA, or DepEd are mandating us to have our blended learning, no? So to incorporate the e-learning in our learning program. Okay. So again, this is Leandro Castillo, one of the technical specialist manager of Hightech Power Incorporated. Together with me is Ma'am Nika Allen Santos, my partner. Today, our topic is all about embedded system. And before we proceed with this presentation, I would like to share to you our webinar overview. So I will have at least 40 minutes presentation and 10-minute Q&A at the end. And all your microphones will be muted throughout the presentation. And if you have any question, you may submit your question or you may drop your question via chat box. So just follow this format for you to address your question. No? So we have here the schools or institution followed by your question. Okay. So again, good morning. So this is the content of this webinar. First, we have the introduction and the available, what we develop in Hightech Power, the laboratory setup for this subject. Available topic, and then the e-learning, and then the equipment also, and all, of course, the complete circuit design software that we are going to use for this subject. Okay, so embedded system is very popular nowadays. It's because unlike before, way back 2015, so there are no subjects such as embedded system. This is just a part of the subject. No? So when the CMO released this 2017, they have the subject focuses on embedded system. Okay, so but in the other country, no, they are taking embedded system for 4-year program because this is a embedded engineering for the other country, you know. So, but here in the Philippines, the good thing is we have the embedded system subject or embedded subject that focusing on embedded system. Okay, so we have that subject on computer engineering. No, we have embedded system, and we also have the former subject, the microprocessor system, no, followed by this embedded system. Okay, so today we are going to talk about embedded system. So embedded system is if you are going to search for a job, like for example, if we're going to check for embedded engineer, so there's a lot of vacant, no? So this is an in-demand job right now. It's because of the development of IoT and development of AI. It's because of the trending topic about industry 4.0. So when we say industry 4.0, it's more about cybersecurity. It's more about cyber control system. So it's something like that. No? So we have to check for the availability of the wireless control. Like for example, if you're going to use the internet using the IoT, and if we're going to use the AI to do the process, you know. So that's the thing. So that's why embedded system nowadays is very important. So okay, so there's a lot of topic that we have to check. No, there's a lot of skills that we need to study for us to be a embedded engineer. So one of the topic is about programming. So there's a lot of programming language. So we have the C language, we have the assembly language, we have the Python, we have the C++, and so on. And the very popular language right now is the right now in this current situation, the very popular language is Python. Because of the fast-growing industry, they are using Python to develop the system. No? And aside from Python, we have the hardware description language, or sometimes we call it the VHDL, or we call it Verilog, so something like that. Okay, so but before that, so I have here the software that we are going to use for to learn, no, how to use this, how to do this subject online. Okay, so we have here the HPI Complete 3D Circuit Design Software and Simulation. So the good thing about this software, it comes with an online version and an offline version. Okay, and aside from that, so the good thing and the difference between these two version, in offline version, you need to purchase the perpetual licenses. Okay, and after that, you have to, of course, you have to install it in your computer for you to use the full capabilities and function of this software. And in case of the updates in component, for example, there are some updates on the component. For example, they made or they develop a component after a month or after this year, so you can update your offline version for free. So that's the good thing about this software. Unlike in the other software, you need to pay for the upgrade version, for the updates, no? But for the upgrade, like for example, right now we are using version 12, and suddenly, shall I say, after these 3 months after this year, they develop a higher version, or let me say version 13. So in upgrade version, if you wish or if you want, no, to upgrade your offline version, all you need to do is to pay for the upgrade package, or what we call it the price difference between two versions. So you don't have to pay for the whole software, no? Okay, but in online version, as long as you subscribe yearly, you can use the newer version. Okay, and of course, there's a lot of capabilities of this software. So sometimes we can say, oh, there's a lot of software right now, same as this software. But this software, I tell you that this is a very unique software that we can use for our, like for example, this subject, no, or the embedded system, no. But we can use this also in some area, in some subject, no. So I will discuss with that later. Okay, so first features and first capabilities of this software is we can use it for schematic diagram, of course. So there's a lot of software that can be used for schematic design. Okay, and most of the software focuses only on simulating the design, simulating the circuit. And we can have the separate software also for creating a PCB layout. But here, in one software, we can create, or we can use this for two functions. We can use for schematic diagram, we can use it for PCB layout, and we can use this also. Another feature, we can use this for interactive animated 3D view. So when we say interactive animated 3D view, whatever changes may happen to your schematic diagram, it always reflects to your animated 3D view. And I said this is an interactive animated 3D view because when you wish to control your circuit, like for example, if you have some switch there and then you have to switch on and switch off, you can do that in interactive animated 3D view. And also you can do that also in a schematic design. Okay, and the good thing about the PCB layout, the PCB layout, you can export the file into a Gerber file. The Gerber file is the file format or standard file format for a CNC PCB maker. Okay, so like for example, in ASEAN Skills Competition, they have the PCB maker. So the competitor, or shall I say the contestant, or the entry, so they need uh, to create or to design their PCB, and then later on they have to send it to the PCB maker. Okay, so we can use this also for that, no? And of course we can use it manually. We can save the file for a picture file like bitmap, like JPEG, and so on. Okay, So another unique feature of this software is by having this one. So we have the 3D model enclosure import. So if you want to see your design for an actual, or like let me say you want to see the actual design of your, or the actual picture of your project or your design, and all you need to do is to use the third-party software. We have the AutoCAD, we have the SolidWorks, we have the Solid Edge, and we have the Google SketchUp, because Google SketchUp is very popular because this is a free software. But if you wish to use the industrial version of this software, you can just subscribe or just pay for the serial number and so on. Okay, after creating your 3D model, you can import that design to this software, like what I'm going to show you here. So as you can see in my screen now, so we import, or we have here some example that they import the 3D model enclosure for them to see the actual picture of their project. Okay. Okay, for the next features and capabilities of this software, we have this for circuit analysis, okay? Because this software not only focus for designing a circuit, not only focus for simulating the circuit, but it focus on how to understand the circuit that you are going to create, okay? So that's why circuit analysis is very important, okay? So you have to understand your design. Like for example, if you want to design an IC, or you want to develop a component, and then you have to understand each parameter. You have to understand each pin, output pin, and also an input pin of your design. So you have to analyze, no? So the good thing about this software, we have the circuit analysis. We have the DC analysis. We have AC analysis. We have transient analysis. We have digital. We have Fourier. And then we have symbolic analysis, and we have the noise analysis. That's the good thing about this software. Okay, and also the good thing is you just need to set for your start display and end display. Okay, you don't need to use or to do, like for example, in if you are going to check for the characteristic of the diode in actual scenario, for you to see, or for you to capture the moment of the rising signal, for let me say, because in the theoretical in the theory, we said that in 0.07 the voltage, no, will rise. So in actual laboratory, we used to use our oscilloscope to do that, no? After putting, or after turning on the power, so we need to pause, or we need to stop the oscilloscope for them, for the oscilloscope to capture that moment. But here in this software, all you need to do is to set for your start display and to set for your end display, and that's it. Okay. So the good thing, you can adjust, no? You can adjust, you can mix the signal, okay? Or you can use like this one, or we can separate each signal, or for each output pin. Okay, so that's a good thing about this one. And another feature is by having a bill of materials. Okay, so you don't need to count each component, no, one by one. So all you need to do is to select the bill of materials, and this will be your documentation, no, for you to have your list of your component. Okay, and another feature also is this one. So that's why I told you that this software is the very powerful software that we can use for embedded system, because it has a support for microcontroller and FPGA. So most of the microcontroller right now is being used for embedded system. And of course, when we say embedded system, this not just uh, a newer system, but this an embedded system is a old I'm sorry about that. So see, the embedded system is the thing that we used before, no, but in we use it as a form of a microprocessor before, but right now we use it as a form of microcontroller. So that's why there's a lot of microcontroller right now. So we can use, like for example, this one. We have here the 8051. We have here the Arduino. We have the ARM. We have the PIC microcontroller. We have here the microcontroller for Texas Instrument, and so on. Okay, so like for example, in a science skills competition way back 2016. So in electronic side, in the 3-day competition, in the first day they have to design the PCB layout. They have to uh, to put all the components on the PCB, and for the third day they have to program. No, they have to use on that moment on way back 2016. They use a PIC microcontroller for the microcontroller. No, and the good thing, you can use this also, this software to study and to practice the microcontroller, no, on how to program the PIC microcontroller. And last ASEAN skills competition, they have the microcontroller. They have the 8051. No, they use 8051 for the microcontroller, but for supposedly we have the ASEAN skills competition right now this June, but they already moved in 2021. Okay, and we don't know if they are going to use Arduino, or if they are going to use the Raspberry Pi, or it's up to them, no. But the thing is, this software is very powerful. It's because you can use this for studying, or for learn how to use the microcontroller, and how to program this microcontroller. Okay, so that's the good thing. And of course, we can use this also for FPGA. Okay, the FPGA is the field programmable gate array. Is the very powerful tool right now. No, it's because in the fast sending of data, capabilities of this chip, or this component. So this is a very powerful component right now. If you're going to visit the altera.com, you can see a lot of development in FPGA. No, they use this chip right now for the computer box of an automotive. No, so unlike before, they use Texas Instrument to have their computer box. No, but right now they use FPGA, and Intel right now is the FPGA right now, the Altera right now is part of Intel. No, in Intel they develop a microprocessor with they can incorporate the FPGA inside. No, so instead of putting or inserting a RAM to make the computer more faster, they just develop the microprocessor with the integration of FPGA, so that the RAM right now is programmable up to 1 terabyte. So if you are going to imagine, right, 1 terabyte RAM, no, how fast is that? Okay, and of course the other feature for the software we have here for VHDL and Verilog. Okay, so CHED right now is mandating us in computer engineering area. They have the subject for advanced logic circuits, no, in advanced logic circuit, and they have also the introduction to HDL. No? They have the subject for that. So we have here the support also for VHDL and Verilog, because VHDL, or hardware description language, right now is very popular. It's because they can use this software, or they can use this program to develop a software. They can use this program also, like for example, in semiconductor company, when they are developing a component, when they are developing an IC, so they are using hardware description language. And in electronics engineering, they have a elective subject. For example, they have the microelectronics subject, no, for their electives. And they can use also, and then one of the topic there is to use the hardware description language to develop their own component, or to develop their own IC. Okay, so that's why there's a lot of semiconductor company right now using hardware description language to develop their own IC, to develop their own component. Okay, so and we can use this also for Verilog, because even today there are some people are too very much popular in Verilog, and there are some people they are too very popular, or they are always use VHDL, and they are always comparing these two hardware description language. No, so it depends on you. No, if you are familiar with VHDL, so you can use VHDL. If you are familiar in Verilog, you can use Verilog. As you can see here in the screen, we have a lot of version of Verilog. We have a Verilog A, Verilog AMS, no, and a lot more. Okay, so the good thing, we can use this software to develop our own program, and later on, after developing that program, you can create a symbol, no? Like for example, if you are going to develop a component using your VHDL, you can create that program, and later on, we can use that program as a symbol, and that symbol, we can use that for another a schematic design, no? We can combine, no, the graphical method and then the programming method. That's the best thing of this software. So unlike in the other software, if you are going to use the VHDL, so you have to use the other third-party software. But here in this software, all-in-one, no, all-in-one software, we can use a lot of things. We can use this for VHDL. We can use this for microcontroller, for DC circuit, for AC circuit, for electronics, and so on. Okay, so another features and capabilities of this software by having this electronic rule checking. Okay, electronic rule checking is very effective way to check your circuit if there are some error and if there are some warning. Okay, like for example, if there are some hanging component, so this ERC will check if there are some hanging component, no? And if there are some warning, like for example, if there are what we have here in the screen, we have here a duplicate reference. If you have a duplicate reference, you will going to have a error if you are going to use the PCB layout. Okay, so that's why duplicate reference is some kind of error, but here is just a warning, no? Because if you don't want to make a PCB, so it's okay. But if you want to use or to create a PCB for your circuit, so you need to check for the duplicate of reference, no? Okay, so another feature and capabilities of this software by having this one. No, you can use this for education and training, of course. So as you can see here, we have here the other tab, no, for education and training, or another menu or another settings, no, for education and training, that you can use this for training purposes, and we can use this for examination purposes. So okay, so meaning to say, you can create your own content. No, you can put all your use this for your learning system to put on all your content, no, to create your own learning program, no, or learning material, no. You can use this as your learning material. You can put some text, no, like for example this one, no. You can create a question like this, no, purely text, no. So like for example, if this is your pre-quiz or pre-test, no, for the students, you can use this for your pre-test, and later on you can use this also for your post-test. Okay, like for example, we have here the full text problem, no, or question that answerable with a multiple choice. We can use this one. We can use like that. And of course, not only for text, purely text. Now we can insert also even picture, even a symbol, even formula, even diagram, or even a component, no, inside your learning material. Okay, to make it more accurate, or to make it more for you to justify every angle of your learning material, so you can use this also to insert those things. Okay, you can use this also for problem solving. Okay, so or for example, you are going to discuss the RLC, no, the resistance, inductance, and capacitance. And while discussing RLC, you have to create a circuit, no, for this three component. You have to create a circuit for for your student to understand, no, about RLC. And you can use this software to instead of using your whiteboard, you can use this as your whiteboard. No, you can use this to put all the necessary things for them to understand how it functions. No, for them to understand about the RLC or about the topic that you are going to provide them. Okay, so you can use the problem solving type of question like this one, that your student will have to answer it correctly, and of course they have to put the correct label. Oh, if the question, or if the answer need to have the correct label, like for example, if the answer is the ampere, voltage, and so on. Okay, so we can use this also for troubleshooting purposes. That's the good thing about the software. So in every circuit that you are going to do, or you are going to create on this software, you can put some, or you can put even for all of the component. Now we can put a fault on each component. Like for example, if you want to short the component, to open the component, or to change the value of the component, so you can do that on this software. And later on, you can use this circuit for your student to troubleshoot. No, like for example, this one. I have here the problem for fault hunting. No, the student must have to check for the faulty component. Of course, before they found the faulty component, they need to calculate for the actual value. Like for example, right now here in the screen, we have to check for the voltage across resistor 2. No, so in the actual scenario, if the circuit is correct, so you can get the right voltage. But if your resistor, or may say the resistor is leak, no, already have a leak, no, and or the resistor is busted or something like that, no, or the resistor is have an abnormal value, so you cannot get the right, no, the voltage at the end. So that's why this is a very important also if you are going to study electronic product assembly and servicing, because in that topic you have to troubleshoot more, no, on the circuit. So that's the good thing about this software. So you can create a fault finding problem, no, for your student to troubleshoot. Okay, and of course there's a pre-made circuit here that we can use for our e-learning content. No, so we have here for the topic for AC, the topic for DC, digital and electronic, because our topic for AC, this is our topic for our electrical circuits too, no? And the topic for circuits 1 is our DC. That's why we have here the DC and we have here the AC. And of course, we can create our own content, no, to make it more beautiful for your student, no, to check for uh, how are you going to provide them the exact information, because some instructor, some professor, they want to create their own content, no, instead of using the pre-made content. Okay, you can do that. So, and of course we have here the topic for digital electronics, for the topic for our logic circuits and switching theory, and we have here the topic for our electronics 1, electronics 2, and of course the good thing about this equipment, this software, we can use this also for our electronics 3. So our electronics 3, the industrial electronics, we use the component to control. No, this is the introduction for power electronics. So we use diac, we use triac, we use SCR. No, so that's a good thing about this software. We have that component here. No, and like for example, this one, no, we have here the pre-made circuit, okay, for a diode, no, for the rectifier. So you can use that, no, or you can create your own, no? And of course the system requirement for this software. So at least this system requirement is for the offline version. Okay, so if you want to have the online version, so this is for for offline version, you need to at least 1 gig RAM. You need at least 1 gig available hard disk space. And of course, you must have a mouse or a VGA adapter, card monitor, and so on, no? Because we will be needing this for your creation of your circuit, no? And of course, if you wish to use the online version, as long as you can access the YouTube and you can access the Facebook, you can do that also, no? So you can access the online version, okay? And for the available topics right now, uh, we are in need of the understanding about this component or about this topic about, for example, we have here the topic for Arduino. Okay, so eh, before the pandemic came, so we have here the equipment intended for Arduino. So these are some of the experiments that we can do. We can do the experiment also using our software, the one that I showed you a while ago, no? Okay, so we can use Arduino, the topic for Arduino. We can program or we can do the activity, no? We can do the laboratory on Arduino using the software that I showed you a while ago. And of course, we can use like what I said, no? We can use this for PIC microcontroller. So I have here a lot of topic about PIC microcontroller, a lot of experiment about PIC microcontroller. And of course, so we have here the Raspberry Pi. So right now, the Raspberry Pi is under development on our circuit design, no? So they are now in the process of developing on how to put the Raspberry Pi on the circuit design. But as of the moment, we can use this also, this hardware, no? So the good thing is you have to combine the software and the hardware. It's because they always said, no, you cannot set aside the hardware. It's because there's a different learning that you can have for hardware and for software, of course, no? That's why we need to use also hardware. So the best practices is to have your online or your e-learning and partner it at least one set of equipment, no, for the actual assessment for your student. Okay, for the next topic, we have here the microprocessor. Of course, we have still the subject for microprocessor system. So that's why we have here the topic for 8086. If you wish to have the topic for 8080, so we also have that, no? So we have the 8086. So the good thing, this component, this equipment, we use assembly language, no, to program this 8086 microprocessor. Okay. And of course, so we have also the CPLD and FPGA, no? If you want to study more about FPGA, so we have that equipment also. With a combination of the software, of course. And I have here the digital signal processor. So this is the another level, no, of understanding the or another level of embedded system, no? We have the digital signal processor. We can use that. So when I remember way back when I was studying my computer engineering, so we use MATLAB, no, to simulate everything. But right now we have the actual equipment to do that, no? We can use this for DFT, FFT, FIR, IIR, no, designing as oscillator, digital process, and so on. Okay, and lastly, of course, the direction of our embedded system is to develop the IoT system or to develop an artificial intelligence. Okay? It's because in IoT, okay, they from 7 OSI layer, because I remember we used to memorize the 7 OSI layer, no, from application to physical, physical to application, and so on. And here in Internet of Things, they said that they only have 3 layers. So first is the perception layer, second is the network layer, and the third is the application layer. In the perception layer, these are the very important because these are the job for embedded system. It's because enable to understand. No, that's why the layer is called a perception. It's because of the signal being fetched from the sensor. No, enable to understand the signal. So we need an embedded system to interpret the data, to interpret the signal, and later on send it via network layer and to our application layer. Okay. So the good thing about this equipment also, so as you can see here in my screen, we have here a Internet of Things equipment. No? So the good thing, we can use this four protocol. As you can see here, I have here Wi-Fi, Zigbee, Bluetooth, and NOcean. Okay, so in this four protocol, okay, so unlike in the other equipment, no, they are claiming they have the IoT system is because they focus on Wi-Fi. Of course, if we are using Wi-Fi, we can say that this is a IoT, no? Because they said this is an Internet of Things, but not only Wi-Fi, not only internet, no, but we can use also other signal. Like for example, this one, we have the Zigbee, we have the Bluetooth, we have the NOcean. And then the good thing about this equipment, we can control it at the same time. No? We can, like for example, if the Zigbee is down, so you can use the Wi-Fi, we can use the Bluetooth, and then we have the latest technology, we have here the NOcean. Okay? For you to understand about the NOcean, there's a lot of support here in the YouTube, in the internet, no, in the Google about NOcean technology. So they always said batteryless and wireless control. That's the marketing strategy for that. No, they have the batteryless and wireless control. Okay, so we can use this equipment. Of course, we have the equipment for the IoT entry in our ASEAN Skills Competition. We have here this equipment, the one that they use in ASEAN Skills Competition, because right now we don't have any delegates, no, for this entry, no, because this is a new entry for ASEAN Skills Competition. So that's why we need to study about the Internet of Things. So the good thing, we have this in our office. Okay, and of course the direction also for this one is behaving this big data, no, for you to understand how to save all the big data, like the data that we upload in the YouTube. So that's why we have this, no? We have to understand also the big data. Okay, so I think this is two of the last slide that I have here. So again, this is our embedded system laboratory. So before we use this laboratory, but of course, right now this is not applicable for this situation. Okay, so we are now developing another set of this kind of laboratory wherein we use a 1 meter distance between the chair, okay, and between the table and so on. Okay, for the recap of for this presentation, so I already discussed about our laboratory setup. I already discussed about the available topics. So of course, our complete circuit design software, as I have mentioned a while ago, that I have an online and I have an offline version. If you want to know more about this software, you can inquire this software to us. Now we can provide you with the demo version of the software for you to explore everything about the software. Okay, and of course about the equipment and e-learning that we have. No, so and before I end this presentation, I would like to leave you this quote from Albert Einstein. So he says, insanity doing the same thing over and over again and expecting different results. No? And of course, we have here also from Benjamin Franklin, the only thing that is more expensive, no, than education is ignorance. Okay, so once again, this is Leandro Castillo, one of the technical specialist manager of High Tech Power. So together with me is Ma'am Nika Allen Santos. So if you want to know more, or if you want to attend more webinar session like this, no, so we have a lot of free webinar session. No, just visit our website. We have the www.hightechpower.net. But right now we are developing another website. We have the ll.hightechpower.net. So maybe we have to transfer some of the content on our old website. Okay, just visit our website and check for the available webinar schedule. And of course, we have the Facebook account, so you can visit that also. So we have High Tech Power Incorporated. So just check for the High Tech Power Incorporated and check for the available schedule for other specialization. So we have a lot of specialization in our office. We have the electrical, we have for mechanical, we have for automation, we have for sciences, we have for ICT, we have for civil, we have for welding, we have for CNC, we have for automotive. Of course, we have for electronics, we have for computer engineering, and so on. Okay. So again, thank you very much for your time. If you have any question, if you have any inquiry, just feel free to send us your question and your inquiry, and we are glad to answer all of your questions. So again, thank you very much. Have a good day, everyone.